Hello there and welcome to Multirate Signal Processing Seminar 1. So this is your first graded assignment, and this time there is a task that is filter design. So basically it's a filter revision. So at this point you should have seen filters before, or in some signals and systems course, or in some basic signal processing, or in some electronic circuits. So what you need to do is to design a low-pass filter with a stop band frequency f-stop that will be given when you run a cell here. This stop band frequency is the start of the stop band. The other requirements of this filter is that the pass band's ripples, they are less than 1 dB, and the stop band attenuation is of at least 60 dB. The stop band should start at the normalized frequency f-stop, with 2 pi being the sampling frequency, and this filter needs to have a transition band of width 0.1 pi. For this task, you are going to use the remes function. To generate the stop band frequency, you need to enter your student ID here. So don't forget to remove this not implemented error. Then you put student ID equals to, so let's use our Jimi 6927. Then you run this. Next you run this cell. So the student ID Jimi 6927 needs to generate a filter where the stop band frequency, so the beginning of the stop band, the start of the stop band, needs to be 0.95 for this number here. So the question 1, we just want to know that if the sampling frequency is 48 kilohertz, what is the f-stop frequency in hertz? This is not in hertz, so how do you calculate this in hertz? Next, what is the required transition band in hertz? So the transition band is 0.1 pi. Just remember that 2 pi is the sampling frequency. So what is the transition band in hertz? Then your answer should be rounded to 2 decimal places, and you can use as many lines inside this function here. So this is a function that takes 2 parameters. One is the f-stop that's given here. The other one is the transition band that needs to be 0.1 pi. Then inside here you need to do your calculations. So this function will return the f-stop in hertz and the transition in hertz. So you could do something like f-stop hertz equals to crazy function that you put your f-stop that you got from here. Then it will return the f-stop in hertz, and you could also do your transition in hertz. It's equal to another crazy function. Then you would run this cell here. So you run the first cell, then you would run here, and this would test if your function is working properly. Your function failed because it doesn't exist a crazy function. But suppose that you do some calculations and your f-stop in hertz would be, let's say, 2000 hertz, and your transition band would be 100 hertz. So now your test failed because this is not the correct answer. Just have in mind that we're running tests here for different f-stop and transition. You are supposed to use this f-stop here, and the transition band is given here. your function should give the right results no matter which f-stop or transition band you use. So you could simply, for example, take this here, copy here, and you take this here and you copy here. Well, now your test didn't fail this test here, but your answer is obviously wrong. The next task is to calculate the filter coefficients by completing this function here. So don't forget to remove your not implemented code. So now this function takes as parameters the stop band frequency and the transition. So you would do something like your coefficients is some crazy function that is a parameter f-stop and transition, and then it's returning your coefficients. Then you would validate your answer, and we are testing the same way that we tested before. So we have different stop frequency for the stop band and different transition width. Then we will test if your function passed these different ones. So then if you try to run this, there will be an error because the crazy function is not defined. But let's pretend that you got some coefficients that would be 10, 6, 27, 69, 666, 2. Then you run the cell and you try to validate, and your test failed. Just have in mind that if you pass for these values here, it doesn't mean that your function and your solution is correct, because this function here should return the filter coefficients no matter what is the frequency of the stop band you're using and no matter what is the transition width you're using. So it needs to pass this test for these frequencies, but also for the frequencies that you were assigned. So for this value here and for this transition bandwidth here. Just an example. I will not show you the solution, but I will just solve it and I will show what happens when you pass the test. So I have here my secret function with the answer, and now when I run this cell, it's printing the filter coefficients, and you have here your obtained frequency response and your design limits. So once you have your function working properly, and you can save your notebook and submit your answer. So I wish you good luck. I hope you understood what you need to do, and I see you next time.